Okay, so for problem number one, what we have is a mass of 2 kilograms attached to a spring, and it's applied a force of 20 newtons, and it's 2.2 meters away from the cable point. And where we are asked to find first is the force constant, and we're going to use this equation that is a combination of Newton's second law with Hooke's law, and we solve it for the K. It's going to be equal to the absolute value of the force over X. It's going to be equal to 20 newtons over 0.2 meters, and that's going to be equal to 100 newtons over meters. So this is the force constant. Then we're asked to find the frequency of oscillations, and first we know that omega is going to be equal to K over M, and we are going to substitute the values. We already have the K is equal to 100, and the mass is 2 kilograms, and we get that is 50. And we just solve the root square, and we get that the frequency is going to be the root square of 50. Then the maximum velocity, we find it with the amplitude times the frequency squared. Maximum velocity, we have the formula that it's the amplitude times the frequency. And the amplitude, we have that it's 2.2 meters. I still super fuzzy, yeah, but times the root square of 50, and it's going to be equal to 1.41 meters over second. Then for the maximum acceleration, we use a similar formula that it's amplitude times the frequency squared. And again, the amplitude is 0.2, and the frequency is going to be just 50, and that's 10 meters over second squared. Then the total energy, we find it with the yeah. Okay. We find it the kinetic energy, it's going to be 1/2 of K times the amplitude squared, and we just substitute the values. 100 and amplitude is 0.2 squared, and we get that it's 2 joules. And finally, we're asked to find the velocity and the acceleration when the amplitude is equal to 1/3 of the original one. And we get that it's the root square of K over M times A squared minus X, and we get that is 1.33 meters over seconds. And the acceleration, it's gonna be this formula that it's the frequency squared times X, and we get that it's 50. And then is the X, the new X is over 1/3, so now it's over 3, sorry, and we get that this result is 3.33 meters over second squared. For problem number 2, we have 2 different masses, and the mass 1 is attached to a spring, and they ask us to find the maximum amplitude that the mass 1 can have, so that the mass 2 doesn't slip away from it. So first, we know that we have the mass 1, and there are 2 different forces in it. We have the force of oscillation and the force of friction. Sorry, this is mass 2. Okay, so what we're gonna do? Yeah. Okay, so first we know that from Newton's second law that the force is given by the mass times acceleration, and we're just considering the mass too. And then we don't know the acceleration, so we're going to use the formula for the solution, that's the amplitude times the frequency squared. And we know that the frequency is equal to the root square of k over m. So what we're gonna do is that we are going to substitute this value in this formula. Well, in this one, using this acceleration, we get that it's the mass 2 times a times here over the two masses, that it's mass 1 plus mass 2. And then for the friction force, we know that the friction force is equal to the friction coefficient, and then natural force. And we're just going to equalize them because we want the maximum amplitude. So we want that the mass doesn't slip. So what we're gonna do is that we put mu times the mass 2 times gravity equals this equation, that is mass 2 times a times k over mass 1 plus mass 2. And then we get that the amplitude, that is what we're looking for, we solve it by this formula here. So it's over k. And the problem gives us each one of these values. So if we substitute them, we get that the result is 0.02 235 meters. That's the amplitude.